In this class, we are going to talk about some angles related to friction. There are two types of angles. One is the angle of friction and the other one is the angle of repose, right? So what is angle of friction? See, the angle of friction is simply, see, there is an object which is about to move. A force is applied on the object in this direction. That means the object will try to move in this direction, but the friction is trying to prevent that. So the maximum friction is reached. That means the friction acting on the object is a limiting friction. So that is the maximum friction. Okay, now, so there is a normal force. See, normal force is a contact force and so is the frictional force. Now we find the resultant of these two forces, right? Normal force and frictional force. So the net contact force is in this direction, right? The resultant of these two forces. So this is the resultant of these two contact forces, normal force and also the frictional force, right? Now the angle between the normal force and the resultant of these two, right, that is called the angle of friction. That's all, right? So very simple. So the resultant of normal and friction and also the normal, so the angle between them is called the angle of friction. All right, so what is that angle? So you can easily find that angle, right? See, first of all, okay, so this is a triangle, right? So let us take this is a resultant. That means you can complete that rectangle. Now let us find, suppose this angle is theta. So what is tan theta? So tan of that angle, so we will find tan theta. In that right angle triangle, tan theta, so that is opposite side, right? Opposite side, that is the magnitude of the frictional force, right? Frictional force. So that means, so that is the frictional force. All right. And then divided by the adjacent side, that is a normal force. So F divided by normal. Okay, so that's all. So this is the formula for tan theta. But you can simplify this. What is the formula for frictional force? Right, that is mu multiplied by the normal force. See, actually it is a limiting friction. But in this case, this is the maximum friction. This is the limiting friction. But we are going to consider the limiting friction to be equal to kinetic friction. So we are not going to consider difference between the limiting friction and kinetic friction. Mu k, mu s value is taken to be just mu only. So that means F can be written as simply mu multiplied by the normal force. Alright, so that is the formula for frictional force. So divided by N. So that's it, N gets cancelled. So we are getting the value of tan theta to be just mu. That's all. So that is the formula for angle of friction, theta equal to tan inverse of mu. So that's all. So if you know mu, that is the coefficient of friction, then the angle of friction can be directly written. So that is tan inverse of that. Alright, so that is called the angle of friction, right? Yes. Now if the friction is more, so the value of mu is more, right? So more the value of mu is, then the angle will be more, right? So the angle will increase, right? If friction is more, this force is more. Now this angle will increase. That means more the value of theta, more is the angle, the friction or the coefficient of friction. Alright, so that is the formula for angle of friction. See, similarly, we also have another angle called the angle of repose. See, angle of repose is more important than angle of friction because we don't use angle of friction much in our questions, but angle of repose is important. But angle of friction, that has formula, this one, tan theta equal to mu. Alright, yes. Next one, the angle of repose. So what is angle of repose? See, this is an inclined plane and we have placed a block on this plane. This block is not sliding because the friction is acting against the gravitational force. So these two forces balance each other. So this block is not moving. Now you increase this angle, right? Increase this inclination. Now there is a point at which the block starts sliding. So that angle is called angle of repose. So now if you keep the angle less than that angle, this block will stay in that position only. Now if you increase that angle to that point, this will start sliding. So that particular angle is called the angle of repose. Okay, yes. So that is the minimum angle of that inclined plane so that the block starts sliding. Okay, so that is the angle of repose. Alright, so let us derive a formula for this angle of repose. So this is the point at which the block starts sliding. That means the friction acting on the block at that point is the limiting friction. Okay, yes. Now let us write all the forces acting on this block. Okay, yes. What are the forces? Gravitational force in the downward direction, we have to take its component along the plane. Okay, that is one force against which we have the frictional force. Okay, now in the normal direction, what are the forces acting in the normal direction? The normal due to the plane in this direction, and then the component of the gravitational force in the opposite direction. Alright, so let us consider the normal direction. So in the normal direction, what are the forces? N is acting in this direction, okay, N, and minus the component of the gravitational force in that direction. So this angle is alpha. See, alpha is the angle of repose. That means, so the maximum friction is acting when the angle is alpha. So that means limiting friction. So what is the force against this normal force? That is a component, right? So that angle is also alpha. So that means mg cos alpha. Mg cos alpha is against the normal force. So N minus mg cos alpha, that equals 0 because no vertical motion. Okay, next one, along the plane. Now you consider all the forces acting on the block along the plane. What are the forces acting on the block? The component of the gravitational force in the direction of the plane. So that angle is alpha, means 90 minus alpha. So mg sin alpha in this direction. Mg sin alpha. Mg sin alpha minus the frictional force in the opposite direction, the maximum friction. So what is the maximum friction? That is a limiting friction. So mu s normal, okay, mu s multiplied by the normal force. So that must be equal to 0 because it is just started sliding, or it is on the verge of sliding, okay. So then the value is 0. Okay, now this normal is already found, so that can be substituted there. Okay, yes, let's substitute it. Mg sin alpha, okay, equals mu s normal, but normal is mg cos alpha. So that's also mg gets cancelled, and then we get sin alpha divided by cos alpha, so that is tan alpha. So tan alpha equal to mu s. So that's also, this is the formula for finding the angle of repose. Okay, so that's it. So that is the angle of repose, or we can say that alpha equals tan inverse of mu s. But in most of the cases, like we discussed, mu s, mu k, right, both are taken as same value only. That means you simply denote this by mu, right? That is the angle, that is the coefficient of friction, right? So no, separately we will not consider the coefficient of static friction and kinetic friction. Mu x can be simply written as mu only. So alpha equals tan inverse of mu. So that's all. So that is the formula for finding the angle of repose. Okay, so that's all. But if you observe, this formula is same as the angle of friction, right? Angle of friction also tan inverse mu. So here also we have tan inverse mu, but these two are different angles, right? But the formula, the value happens to be same. So there also we have the angle of friction, we got tan inverse mu, and here also we have this tan inverse mu, same formula, but these two are different angles, right? Their definitions are different, but the numerical value happens to be the same value, tan inverse of mu. So this is the minimum value, okay, for the block to slide. Okay, yes. Now whether the block slides or not depends on the angle. Suppose the angle is more than this angle. If the angle of the inclined plane is more than this angle, the block will move. If this angle is less than the angle alpha, this object will not slide, right? So it will stay in equilibrium position only. So that means, so if you want to know whether the block is moving or not, you have to find the angle of repose and then the angle of the plane, right, inclined plane. So that is more or less than this angle of repose. Accordingly we can decide whether this block is sliding or not. Okay, so this is one formula that you have to know, right, the angle of repose. Okay, now let us do some simple questions based on these concepts. Okay. Here a block is kept on an inclined plane. We have to find the accelerations of this block in these two cases, right, when theta is 30 degree or 60 degree. We know that the object slides, it moves only when this angle theta is more than the angle of repose, right? So this angle theta is more than alpha, then the object will slide, otherwise it will stay in that position only. Alright, let us see whether this angle is more than or less than alpha. Alright, so what is the angle of repose formula? So that is tan alpha, right? Tan alpha is equal to mu, but that mu is 0.9. So what is the value of alpha then? We don't know exactly, right? But it is very close to, approximately we can take it to be 1, okay, approximately 1. So alpha can be approximately taken to be 45 degree, little less than 45 actually, alright, little less than 45 degree. Okay, now take the first case. So what is the first case? In the first case, the angle theta is given to be 30 degree. So is it more or less than this angle alpha? So this theta is less than alpha, right? Theta is less than this alpha. When the angle is less than the angle of repose, the object does not move, right? So that means the acceleration in the first case, that is 0. You understand? So that's all very simple. No acceleration. 0. Now in the second case, so in the second case, theta is equal to 60 degree. So which is more than this angle alpha, right? This is close to 45, but this is more than that. So that means the acceleration is not 0. The object moves. So the acceleration is not 0. Then you have to do all the calculation. Okay, let us calculate it. So at least we made sure that the object moves. Now let us calculate it. What are the forces acting on the object? Now the component of the gravitational force and also the friction in the opposite direction. Okay, so that's mg. Okay, mg cos 60, right? So mg, sorry, sin 60. That is a component of the weight in the horizontal, along the plane. Now minus the frictional force. So what is the frictional force? So mu normal. So that equals mass times the acceleration. Okay, yes. But what is this? Okay, now we have to find the normal force. What is normal force? You consider the normal direction. So the component of the gravitation force balances the normal force, right? That means mg cos 60, mg cos 60, right? That is the same as the normal reaction, and mu is also given 0.9. Okay, so that can be substituted, right? Yes, let us substitute it. So this is mg sin 60 root 3 by 2 minus mu is 0.9, and normal is same as mg cos 60. That equals mass times the acceleration. So maybe the mass cancels, and then cos 60 is 1 by 2. Okay, and g is 10. So this is you can take approximately 10. So this is 5 root 3 minus, so take g 10. So 10 multiplied by 0.9. So that is 9 multiplied by cos 60. So that is 4.5. That's all. So that is the acceleration of the block in the second case, right? 5 root 3 minus 4.5. So that is the acceleration of the block. So that's all. So that is the required. In the first case, the acceleration is 0. In the second case, the acceleration is this value, 5 root 3 minus 4.5. Okay. Here an insect is crawling, right, along that curved surface, right? So this is a circular track, right? So it is moving. Now what is the maximum height it can reach, right? So when it reaches the maximum height at that point, so this downward force balances the upward force. That is, what is the downward force? That is the component of the gravitational force. The gravitational force is acting in the downward direction. Now that will make this object fall down, but that is prevented by the frictional force only, right? The frictional force is what makes it move in the upward direction. Okay, now so these two forces balance at that point. Okay, yes. Now this angle is theta, right? Take this angle to be theta. That means you draw tangent at that point where it reaches the maximum height. When it reaches the maximum height, at that point you make angle theta. So that, I mean, the tangent, that tangent makes angle theta, right? Same angle, right? Theta with the horizontal. What is this theta? When it reaches the maximum height, so that angle theta is the angle of repose, right? Which means theta equal to, tan theta equal to mu. You understand? Okay, if you don't want to see directly also we can write, so tan theta equal to mu, because this is the angle of repose, right? So directly also we can write. So okay, if you don't want to use this angle of repose directly, so we can use our basic equations. So what is that? What are the forces acting in the normal direction? So normal force in this direction, and also the component of the gravitation force. So normal, that equals the component of the gravitation force. So mg in the downward direction, take its component mg cos theta. Okay, so n is found. Now along the tangent, what are the forces acting? Now the component of the gravitation force along this, that means mg sin theta, okay, mg sin theta, and against this force we have the frictional force. So what is the frictional force? So minus mu normal. So that equals 0, because when it reaches maximum height, no acceleration further, right? So there it is at equilibrium. Okay, so this gives you our required value. So mg sin theta minus mu normal. So normal is mg cos theta equals 0. So that gives you, alright, so this is mg gets cancelled, so sin theta by cos theta, so that is tan theta. So tan theta equals mu, right? So we can directly also write using our concept of angle of repose, but anyway, otherwise we can use this calculation also to get this value. Tan theta is mu. Okay, yes. So that is done. Okay, now we have to find the maximum height. So we found tan theta. Now it is simple basic geometry. Okay, so the height, right, from the bottommost point, so that level, right, the maximum height, that is taken as h. So that is the radius, right, radius from the center to that bottommost point, that is radius. So radius minus h. In that right angle triangle, what is the value of tan theta? So tan theta we can find, so that is mu. From that we can find, say, cos theta. So what is the value of cos theta? See, in that triangle, cos theta is equal to, what is cos theta? Adjacent side, which is r minus h, divided by the hypotenuse. The hypotenuse is the radius of the circle, so r. That will give you h value, right? So what is the value of h? So r cos theta minus, okay, so we can simplify this. This is 1 minus h divided by r. So that is the value of cos theta. So that will give you h value. H is equal to r multiplied by 1 minus cos theta. So that's all. That is our required h. But what is the value of cos theta? That we don't know. But we know tan theta, right? From tan theta we can find cos theta, right? So that is very simple. So using our triangle method, theta, what is tan theta? The perpendicular, right, the opposite side, which is mu divided by the base, that is 1, mu divided by 1. That means this value is by Pythagoras theorem, it is 1 plus mu square. Okay, Pythagoras theorem. Once the triangle is completed, we can find cos theta. What is the value of cos theta? This one, base 1 divided by 1 plus mu square. So that's all. So that is our 1 minus, so that value 1 divided by root 1 plus mu square. So that is the value of h. So that is our required answer, right? H is what we need to find, right? The maximum height reached by that inside. So that is r 1 minus 1 by root 1 plus mu square. Alright, so that is the required answer. Here we have two blocks kept on an inclined plane. These two blocks are connected by a string. We have to find the tension in the string for different values of mu1 and mu2. See, first of all, we have to check whether these blocks slide or not, right? Whether these blocks are moving or not, so that we have to check. That depends on the angle of repose, right? If the angle 30 degree is more than the angle of repose, then these blocks will slide. If this angle is less than the angle of repose, then these blocks will not move, right? They will be at rest, right, at equilibrium. Okay, now let us calculate the angle of repose. See, what is the angle of repose? That depends on mu1 and mu2, right? So 30 degree. See, we know that tan alpha equal to mu. Okay, so tan alpha, so that is equal to mu. But we have two cases here, right? So mu1 and mu2, because two blocks. Okay, let us take the first case. Theta is given 30 degree. So theta is 30 degree. That is fixed. Now is this angle 30 degree more than this alpha or less than this alpha? So let us consider different cases. Okay, so the first case, it's given that what is the value of mu1? So that is given to be mu1 is equal to 0.9 and mu2 is equal to 0.6. Okay, now first of all, let's calculate tan 30 degree. So what is the value of tan 30 degree? So that is 1 by root 3. Okay, what is its value approximately? We can take it as root 3 divided by 3. Okay, so that is root 3 is what, 1.7 approximately, so divided by 3, so it is less than 0.6, right? 1.8 is 3 times, 6 times, so this is less than 0.6, maybe 0.55. Okay, approximately you take, approximately. Okay, so 0.55. Now let us check whether this angle mu1 is greater than or less than this. See, 0.9, that is obviously greater than 0.55. Okay, and 0.6 is also greater than 0.55. That means this angle tan, right, alpha. See, in the first case, the angle alpha. Okay, tan alpha. In the first case, tan alpha, that is mu1. The tan alpha is mu1. So that is greater than the angle given, right, theta, tan 30. That means alpha is greater than 30 degree. If the angle of repose is greater than this given angle, that means the blocks will not slide, right? So here also you take Here also we are getting the same thing. So tan alpha is greater than tan 30. So in both the cases, which means alpha is greater than 30 degree. In this case also, in both the cases, this angle is less than the angle of repose. That means the blocks, both the blocks do not move. They have no tendency to move only. Okay, so they don't move. When these two blocks are at rest, then what is the tension in the string which connects these two blocks? That is zero, right? Because both the blocks are not moving. Okay, tension is zero, right? Because there is nothing to create tension in the string, right? So nothing to create. Suppose this block is trying to move, that block is at rest, then there will be tension created, right? So there is nothing that will create the tension in the string. Both the blocks are at rest, so no tension. Tension is zero. Okay, done. Okay, so that is the first case. Second case. Second case, what is that? Mu. Okay, so that means no friction only. So mu1 equals mu2 equals 0. When there is no friction, what is the acceleration of the 2 kg block? Acceleration of the 2 kg block, that is same as the acceleration of the 3 kg block, na? Because both will have the same acceleration, because they will have the same horizontal component of the acceleration. I mean component of the acceleration along the plane, right? Because same acceleration, because nothing to prevent that object from sliding. When these two blocks move with the same acceleration, what is the tension? Again zero, right? Because they are moving with the same speed, suppose, right? They are moving with the same speed. That means no tension is created. Suppose this 2 kg block is moving faster, then that creates tension. You understand? So here both are moving with the same speed. That means no tension is created in the string. So again tension is zero. So in the first case also tension zero. Second case tension again is zero. But the tension is zero for different reason. Here both are moving with the same speed. Here both are at rest. Okay, so in any case the tension is zero in these two cases. Now the third case. The third case, what is that? Okay, so mu1 is 0.3. Okay, so mu2 is 0.6. So mu1 is 0.3. Okay, so that is less. That means this time, okay, so angle alpha. This time angle alpha, right? See 0.3, right? That means T alpha is less than tan 30. Sorry, alpha is less than 30 degree. That means the object moves. Alright, so 30 degrees greater, which means the angle is more than the angle of repose. That means it moves, which means it has some acceleration. Okay, now the second case, the mu2. So mu2 is given to be 0.6. So 0.6 is more than the angle of repose. So this time alpha is greater than 30 degree. That means the object does not move. But there is a tension force acting on the object, right? So the tension may make the object move, right? So we don't know. So the tension is also there, right? Not only the gravitational force, the tension is also there, right? If only gravitational force, this object does not move. But we also have the tension due to the string, right? Because the other object is connected to the string that is trying to move. So tension will also try to drag this object. So this object may move still. So but because of only the gravitational force, the object does not move. Okay, yes. Now suppose this object is dragging that object also. Both move with the same acceleration. Okay, because this is moving. So this will pull that object also. So both move with the same acceleration. So let us find the acceleration. Okay, yes. How to calculate? So let us write the forces acting on this object. What is that? The component of the gravitational force. So what is that? mg. mg means 2g. 2g and its component, right? So it is sine 30. 2g sine 30. So that is its component, and tension is acting in the opposite direction. So minus tension. And also we have the frictional force acting in the opposite direction. So what is the frictional force? So minus mu. So mu is what? 0.3. So 0.3 mu mg, right, component, the normal force. What is normal force? Normal balances the component of the gravitational force. So normal equals mg cos 30, right? Mg cos 30. So 0.3 multiplied by mg. M is what? 2g cos 30. This equals mass. Mass is 2 multiplied by the acceleration. So that's all. This is equation number 1. Okay, yes. Now for the 2 kg block. Okay, so this is 2 kg block. Similarly, for the other block, 3 kg block. So what are the forces acting on that block? Again, gravitational force. So 3g instead of 2g, 3g sine 30. but the tension is acting in the downward, right? Tension is pulling this object, right? Downward direction. So plus T, right? Not minus, plus T. Okay, and frictional force in the opposite direction. So that is, yeah, so this is 0.3, here it is 0.6. So minus 0.6, 3g cos 30, that equals mass times the acceleration, so 3 times the acceleration. So that's it. We just need to solve these two equations to get the value of the tension. Okay, so how will you solve this? So you can just subtract it. If you subtract these two, so we will get, sorry, if you add these two, this t will get cancelled, we will get the acceleration. Okay, so that's all. So we'll get, if you add these two, what do you get? 2g sine 30, 3g. So sine 30 is 1 by 2. So 2g plus 3g, 5g divided by 2. So 5g divided by 2. Okay, this gets cancelled. So what is this? Yeah, cos 30 is root 3 by 2. Okay, so if you simplify, so this is root 3 by 2, 2g. So g root 3 by 2, so minus g root 3 by 2, if you take out, you will get 2 multiplied by 0.3. So that is 0.6, and 3 multiplied by 0.6. So that is 1.8. So 1.8 plus 0.6. So that is 2.4. Okay, so 2.4. That equals 5a. So that's all. So that will give you the acceleration of the object. So once acceleration is found, so substitute this acceleration here in one of these equations, you will get our required tension. Okay. If you take the value of g to be 10, right? So 10 divided by 2 is 25. 25 minus, so 5 root 3 multiplied by 2.4. So that is 12 root 3. So that means, so we are getting the required acceleration. So that is 25 minus 12 root 3. Okay, we've got the acceleration. So 25 minus 12. So that is the acceleration. But we want the tension. See, this acceleration is a positive value or negative value? 25 minus. So this is smaller than 25. It is a positive value. Suppose you are getting acceleration as a negative value. That means the object move in the opposite direction. But that is not possible, right? That means our assumption is wrong. We assume that both the objects move with the same acceleration a. But we got a negative answer. So that means our assumption is wrong. So the objects do not move because the movement of this 2 kilogram object is prevented by the other object, right? So but here we are getting the acceleration positive only, so no problem. So if you get negative, that means the objects do not move. Understand that, right? So acceleration is found, but we need the tension, right? So substitute this acceleration in one of these equations, so either here or here, right? So we'll get our required answer. I'm not doing the calculation, so I'm writing the answer directly, but just substitution, right? Just substitute the acceleration in one of these equations, you will get our required tension. So that is, okay, so I'm writing directly here, 9 root 3 divided by 5. Alright, so you should get this as the answer, 9 root 3 by 5. That is the required tension in the last case. Okay, so in this case, right, when mu1 is 0.3, mu2 is 0.6. Alright, yes. In other two cases, we got the tension value 0. Okay, so that's all. So that is the answer. Here also we have two blocks kept on an inclined plane, but they are not connected by a string. So no tension force between the blocks, but there is a normal force between the blocks because one exerts force on the other, right? Normal force between the blocks. Okay, yes. Now see the block M1, okay, and the surface, so they have some frictional force, right? Because that mu value is 0.3, but the block M2 and the surface, so there is no frictional force between them because mu is given to be 0. Okay, so that means no frictional force acting on the block M2, but there is some frictional force acting on the block M1. Okay, yes. Now what are the forces acting on the block M1? See, these two blocks will slide only when this exceeds that angle theta, okay, is more than the angle of repose, right? Yes, let us calculate that. So what are the forces acting on the block M2? Okay, let us do it one by one. For equilibrium, right, this system should be in equilibrium. For equilibrium, so let us calculate for M2. Okay, what are the forces acting on M2? So M2, so the component of the gravitational force in the direction of the plane, right? So M2g, and then this angle is sine theta, right? So 90 minus theta, M2g sine theta. So that is the force M2g sine theta. And we also have the normal force between these two blocks, right? These two blocks have a contact between them, right? So these two blocks, one exerts force on the other. That means normal force is trying to push this object. See, remember, the block M2 will always try to move in the downward direction. There is nothing to prevent it. The only force against the gravitational force is the normal force between the two blocks. That is in the opposite direction. So minus N. So minus the normal force between the blocks. So that equals 0. You understand? No friction. But for the block M1, so there is a friction also. So what are the forces? Now again, same gravitational force, but instead of M2, M1 G sine theta. But this time, the normal force between the blocks, that is also in the downward direction, same as the gravitation force. So plus N. Because that block M2 will try to push this block in the downward direction. So that means normal force between the blocks is also in the downward direction, plus N, not minus. And then frictional force in the opposite direction. So what is the frictional force? But for equilibrium, remember, this force in the downward direction should be less than the frictional force. It is not necessarily exactly equal. It has to be less than that, right? So frictional force is more than this force, then the object will be in equilibrium, right? Anyway, the object is not going in the upward direction. So the friction prevents the block from sliding. That means the friction should be more than this force. This is a total force apart from friction. So friction should be more than this. So this force should be less than the frictional force. What is the frictional force? So mu N. But N is the normal force between the surface and the block. So that is no component of the gravitation force. So that is mg cos theta, right? So M here is M1. So M1 G cos theta. Do you understand? Now what you do, this N can be substituted from this. Okay. So we get M1 G sin theta plus M2 G sin theta is less than, so this value mu M1 G cos theta. Okay, let us simplify this. So if you divide, you can cancel this G and divide cos theta, we'll get sin theta by cos theta, that is tan theta. So we are getting this one, tan theta is less than, okay, tan theta is less than, what do you get? So mu M1 divided by M1 plus M2. So that's all. But I think the values are M1, M2 are given, right? The mass of the object. So that is 2 and 1. So that means the mu is also known. So that is 0.3. So this value is 0.3 multiplied by 2 divided by, this is 1 plus 2, 3. This means 0.2. So our tan theta should be less than 0.2. That's all. That is the condition for the system to be in equilibrium. Okay. Tan theta is less than 0.2. So what is theta then? It is given in the question itself. You see, so it is given that tan 11.5 is 0.2. That means tan theta is less than 0.2. That means theta should be less than 11 point, okay, so 11.5, yes. If theta is less than 11.5, the system will be in equilibrium. That's all. That's what we have understood. So that means, so take the case, if theta is equal to, see the first question, so theta is given to be 5 degrees or 10 degrees, right? Theta is 5 degrees or theta is equal to 10 degrees. In both these cases, this is satisfied. That means the system is in equilibrium. Because we have only derived the condition for equilibrium. Theta should be less than 11.5, but both these angles are less than 11.5. That means this system is in equilibrium. When the system is in equilibrium, that means the objects are not moving. What type of friction acts on the object? That is the static friction, right? Not moving, static friction. That implies the friction here is the static friction. Static friction does not have any direct formula. So we have to consider the other forces. What are the total forces acting on the object? Consider this M1 plus M2 as one system. Okay, one set. So M1 plus, what are the forces acting on this? So M1 plus M2, gravitational force. So M1 plus M2 G and its component in this direction. So that is sin theta in this direction minus the frictional force. Minus the frictional force in the opposite direction. So that must be equal to 0. Okay, so that's all. So this gives you our required frictional force in the first case. So F is equal to M1 plus M2G sine theta. So that is the answer when theta is 5 degrees or 10 degrees. Okay, in both the cases it is static friction. So that means use the formula for static friction. I mean, consider all the forces, the total is 0 because equilibrium. But when theta, in next case 15 degrees or 20 degrees, when theta is 15 or 20 degree, in both the cases it exceeds this value. Okay, so if theta is equal to 15 degrees or theta is equal to 20 degree, okay, in these two cases what happens, these objects are sliding. That means the friction here is not static friction but kinetic friction. Okay, kinetic friction. What is the formula for kinetic? This implies kinetic friction. So what is the formula for kinetic friction? So when theta is equal to 15 degrees or 20 degrees, the friction here is the kinetic friction, but kinetic friction has the direct formula, right? Yes. So what is the friction here? So the kinetic friction is what? Mu multiplied by n, that's all. So mu multiplied by n. So what is n? The normal force between the block M1 and the surface. Okay, what is that? So that normal force in the upward direction, that is balanced by the component of the gravitation force. What is the gravitation force? M2G, its component cos theta, right? So that means mu M1G cos theta. So that's all. So this is the frictional force in these two cases when theta is 15 degrees or 20 degrees. So in the other two cases 5 degrees or 10 degrees, so the friction is the static friction. So that is formula M1 plus M2G sin theta. So that is the answer.